Hey guys, I'm finally back and I'm so excited to be making another video for you guys, even though I've got some laboratory work to do, which is going to consume my time a bit, but I am here because as promised, we're going to be starting our first robotic project tutorial. Without further explaining, let's just get into the video. I'm excited for you guys to finally see it. Let's go. Hello everyone, it's I'm Johnny, an electrical engineering student in bachelor's degree. In this video I'll be explaining the whole process of making the Bluetooth controlled robotic car. Here's a preview of the finished project. The car is going to be able to move with the HTML controlling app that I programmed. Here I'm switching on the rechargeable batteries and then connecting the Bluetooth module HC05 to the controlling app. And here I'm switching the direction of the car to match the controlling app commands. And we're able to send Bluetooth commands to the module by pressing each of these buttons. Now for the core of this car, I used Raspberry Pi Pico, the Edge model, as the microcontroller, but for the sensor I used STM32, and here's the radar display that I programmed to show a small red dot as the target that's in front of the ultrasonic sensor. Up here we have some real-time information about distance and angle from the target. Later on I decided to elevate the STM32 radar display. As you can see, as soon as the target is detected by the ultrasonic sensor, the background color of the radar display changes. And that's due to the extra conditions I added for the HTML program. In the process of elevation, I decided to add some features to the controlling app. One of them being the battery voltage status for the rechargeable batteries, which is right above the remote control. As you can see, it's not fully charged, so it's at 7.4 volts, and you're going to be able to see it decrease even more. While we talk about the rest of the features, I'm going to insert a video of me testing the controlling app in another time interval. Right here, I'm connecting the HC05 module to the controlling app. Now the other feature that I added is the serial monitor that shows all the real-time commands sent to the Raspberry Pi Pico microcontroller, along with the each command's status of execution. In the serial monitor, you can see some keywords. For example, if I were to push the front button, the Raspberry Pi Pico receives a capital F, and it would run the forward movement command according to all the conditions we added in the code, and the execution will be complete. Also above the serial monitor, you can see the real-time speed, which is measured according to the pressure that is on the DC gearbox motors. Here's an overview of the HTML program for the controlling app. And here's how I decided to design the controlling app. I added 4 buttons for the 4 direction that you can press to send Bluetooth commands to the HC05 module. And up here we'll be showing the Bluetooth connection status, whether it's connected or not. When we connect the Bluetooth module, it's going to turn green and will say that it's connected. Here I decided to add the speed control slider bar to be able to control the pressure that is on the 4 DC gearbox motors. And that's all about the controlling app. Moving on to the radar display, here's how I decided to design it. We are able to connect the STM32 through a USB cable, or we can just use the same Bluetooth module and see the radar display in that form. Now, as soon as we're connected to the STM32, a straight line will appear that moves around this semicircle, rotating from 0 to 180 degrees. And above, some real-time information about the distance and the angle of the target from the sensor will appear. Whoa, wait! you didn't think I was going to show you the whole process in just one video. The project is still going through many tests. I'm trying to elevate it more so I can present it better for you guys. So I hope you see you on the next ones. So come back to see the results.